In this video, we are going to go over the section 2.7 inverse functions notes. So the first thing we're going to do is talk about what it means to be an inverse. So first we're going to graph this function by plotting a table of values. So we're going to use -2, -1, 0, 1, 2. So we're going to plug those in and we're going to get -8, or sorry, -10, -3, -2, -1, and 6. So now I'm going to plot these points. All right, so here's our original cubic function. For every cubic function, we know that our domain and range is going to be -infinity to infinity. Now, we're going to find the inverse of this function. So to find the inverse, we're going to reverse the inputs and the outputs. So to find the inverse, essentially, I'm going to put the y values from the function here and the x values from the function here. So -10, -3, -2, -1, 6, -2, -1, 0, 1, 2. All right, now we're going to plot these points. So -10, -2 be somewhere over here, -3, -1, -2, 0, -1, 1, 6, 2. Okay, so my inverse of this function looks like this. So whether you're looking at the graph or you're thinking about the domain and range, when we talk about the domain and range, the domain of the inverse is equal to the range of the original function. Same with the range. If we're talking about the range of the inverse, it's going to be equal to the domain of the function. I guess I should write these a little bit different. The inverse function. So the inverse of the domain is going to be the range of the original function. So the range of my original was -infinity to infinity. The range is the same as the domain, so -infinity to infinity, and this is confirmed by our graph. The next part of these notes says, is the inverse relation a function? Why or why not? How can you predict? So when we're talking if something is a function, why or why not, we use the vertical line test. And it does pass this test, meaning if I were to draw a vertical line, it would only hit the graph one time. Now, how can you predict by looking at the graph? Because we know that if it's a inverse, the inverse function would have to pass a horizontal line test, meaning if the original function passed the horizontal line test, then that means that the inverse would be a function. So instead of a vertical, we would use a horizontal line. So what's something else you notice about the two graphs in terms of their symmetry? Well, if I were to draw a line right here, this would be the line that mirrors the two functions. So they are symmetrical across the line y equals x. So now they want us to find the equation for f of x. So f inverse of x. So our original function was f of x equals x cubed minus 2. So anytime we are trying to find the inverse function, what we're going to do is we are going to switch x and y. We know f of x is really just y. So now I'm going to find the inverse. I'm going to switch where x and y were, and then I need to re-solve for y. So to resolve for y, I would add 2. So I would get x plus 2 equals y cubed. To get rid of the cubed, I would take the cubed root. So the inverse would be equal to the cubed root, well, because y would be equal to the cubed root of x plus 2. So the inverse would be equal to the cubed root of x plus 2, all under the cube root. All right, let's take a little bit further look at inverses. So it wants to know if the function f of x, x squared plus 5, 1 to 1. Well, this is a parabola that's shifted up 5, so it looks something like this. So yes, all parabolas are 1 to 1. So now it wants us to find the inverse in its domain. So first I'm going to think about the domain and range of this original function. So if I have my little sketch there, I know the domain is negative infinity to infinity, and the range would be 5 to infinity. So now let's take this and let's find the inverse function by switching my x and y and re-solving for y. So my inverse function would equal the square root of x minus 5. And so the domain of this inverse function, we could also think about, I want to go and look at the range of my original function. And so the domain of my inverse function is always going to be the same as the range of my original function. So it'd be 5 to infinity. Let's give this another try. Determine the equation and the domain of the inverse function of this guy. F of x equals 3x plus 1. So I'm going to have x equals 3y plus 1. Divide by 3. The inverse function would equal 1/3 x minus 1/3. You could have also said x minus 1 all over 3. Both would be okay. So then what is the domain for this inverse function? Well, if I think about my domain and range for my original function, this is a linear, so I know that my domain and range would be negative infinity to infinity. So that means if my range is negative infinity to infinity of my original function, that means the domain of the inverse would also be negative infinity to infinity. Let's try one more of these. Determine the equation and domain of this inverse function. So x equals the square root of y plus 3. Square both sides. X squared would equal y plus 3. The inverse function would equal x squared minus 3. All right, my original function is a square root that shifted left 3. So that means the domain of this original function is negative 3 to infinity. The range of this original function is 0 to infinity. So that means the domain of my new function would be 0 to infinity. So we're always going to use the range of the original to determine the domain of the inverse. All right, now we're going to show how do you prove two functions are inverse of each other. So if f and g are inverse of each other, that means when we take the composition will equal x. And same way the other way. If you do the composition the other way, it'll also equal x. So to prove two functions are inverses using a composition of functions, I need to show the composition both ways is going to give me x. So first, if I do f of g of x, meaning I'm going to put g into f. So 5 over x plus 2 minus 2 would equal 5 over x. Well, we're just doing 5 times x over 5 because when we divide by a fraction, we multiply by the reciprocal. So that would give me x. So let's do the same thing, but now I'm going to do g of f of x, meaning I'm going to put f into g. So I'm going to have 5 over x minus 2 plus 2. So again, dividing by a fraction means I'm multiplying by the reciprocal. So I end up with x minus 2 plus 2 equals x. So I want to verify that the composition both ways gives me x both times. And that's how I prove that, yes, these are inverses. All right, so let's say I gave you a point, 3, -1. And they want to know, is this point on the inverse of this graph? So there are two ways to do this. So method number 1 is we're going to use the same way we did it before. We're going to switch our x and y. So I'm going to have 3y squared plus 4x equals -9. And then if I were to resolve, I could get the equation, but I don't need to solve right now. I just need to prove that this point is on the inverse. So I'm going to plug -1 in for y. I'm going to plug in -3 for x. And I'm going to see if the left side equals the right side. So yes, -3, -1 is on the inverse graph. All right, method number 2 is really similar, but instead we're just going to take the point and switch the point. So if I have -3, -1 as x and y, I'm really just going to put -1, -3. So I'm going to leave the original equation, but just switch that now x is -1 and -3 is y. And if you notice, our equations are going to look pretty much identical because it's really the same method, just thinking about it in two different ways. So either way you use is fine with me, but just remembering that x and y are reversed when we're talking about inverses.